Hello all, my name is Akhilesh Paranivelu and I'm currently pursuing my Master of Science in Cloud Computing. I'm from Group B. Today I'm here to give my research topic. I'm here to give a video presentation on my research topic which is based on latency issues and solutions in cloud gaming. Basically cloud gaming is another revolutionary part of the gaming industry where you don't need to really have a good hardware. Even if it's like a low-end hardware, it can actually it can support up to any hardware possible. And also it only requires a network speed. You don't need to download anything. Even if you don't have the game physically, you can still stream online with the cloud server. And the other part of the main challenging part of the cloud gaming is there is a latency issue which is a delay between the user input and the system response, which is a main challenge which is still happening these times. So which actually, not only the latency is the problem on the user input and system response, but it also affects the responsiveness, which is leading to lag, poor animations, and reduced player engagement. Basically, if a player is trying to stream a game via the cloud, and then when he's trying to play the game, at one point of time, due to the latency issue, it provides high frustration, and also which is a very bad experience in the gaming environment. And there are like competitive landscapes like Google Stadia and Nvidia GeForce Now, which is a modern cloud gaming platform by the leading company. But the Google Stadia has lead to downfall only because of the latency issues, which was actually equivalent console to Xbox and PlayStation, but which is completely streamed via the cloud. But due to the latency issue and the input delay, which lead to a downfall. But GeForce Now is still a cloud platform which people can still stream the games, but still the issue is still persisting over there. But there are very less player engagement at the moment. So the main research goal is to address the latency issue in cloud gaming by evaluating the server configuration and also proposing a solution for a better backend performance and user experience. And here I've analyzed with three configurations. The main configuration which I've used over here is let me show you the architecture diagram. So here the architecture diagram is about a user, and I've just created a small block using HTML and jQuery and a little bit of Unity into it. So basically in the block we can able to move the block with using the arrow keys. So in that I have three setups. One is local setup, which is actually considered as a edge server, and the other one is EC2 instance, which is used with the help of the backend of Flask built-in server, and also an EC2 instance with a G-Unicorn server. So basically in the local server, when I'm using the arrow keys, it basically it interacts with the game, and then it sends the input to the Flask backend server, and then the metrics have been completely recorded and it will be sent to the Prometheus client. I've used Prometheus client because even I have two metrics over here. One metrics is like a normal metrics which will record it with using the jQuery, and the second one will be the Prometheus client where it actually collects the metrics and then it shows in the forms of graph. And the second one is Flask built-in server. I have the same game which is being deployed in the EC2 instance using the Flask built-in server and with the same input of arrow keys and the Flask as a backend, and the metrics has been sent to the Prometheus client. And then there's an integration and communication where I've used the EC2 G-Unicorn server, which is actually the current fix which I could come across with the latency. But G-Unicorn is a very built-in and a most advanced server and also very efficient. So where I've used the same game deployed in the EC2 instance using the G-Unicorn server, and where the entire thing is completely recorded in the G-Unicorn backend and it's been sent to the Prometheus. Basically, if I come with the Prometheus server, it actually basically scraps all three of the metrics inside its server, and also the metrics aggregator, which has the scrapped metrics which have been completely used from the communication from the game and to the backend, and from the backend to the Prometheus server. And these metrics have been visualized in the dashboard with the help of metrics visualizing with the help of graphs. And other than that, I've analyzed with three types. One will be the frame rate, input latency, and response time. So and the strategies that I've implemented over here is optimizing the network architecture and backend performance with the help of a virtual private cloud server, and also with the help of a G-Unicorn server. And then other than that, I'm also here to propose a future ready solution as well in the forthcoming presentation. So let's go to the next slide. And basically the experimental setup, as I've showed you the architecture diagram, which has a local EC2 instance with Flask and EC2 instance with G-Unicorn. Basically local setup, it simulates a proximity to the users. Basically the local setup is a normal setup where it's just a normal, there's only one backend. Other than that, it's just a normal game. So it actually runs within the system hardware. And EC2 instance with the Flask server, it actually mimics, actually, like we are considering that as a vGPU server with the help of virtual private cloud, and that flash server is actually the cloud server. And EC2 instance with G-Unicorn is actually like a combination of local and the cloud. But with the enhanced performance, we have deployed it with the help of G-Unicorn server inside it. And then in the metrics monitor, as I've told about the frame rate, input latency, and response time. Frame rate is actually the determines the smoothness of the game, and the input latency, it measures the delay between the user action and the visual response. For example, if I'm just moving the block at like left and right and up and down, the latency has been the latency has been measured with the help of the frame rate and also the input which I've implemented, which I've executed. And for the response time, it evaluates a backend processing speed. For example, if I'm moving the block like up and down, left and right, at one point of time, the response time showcases like how the speed has been processed and how the movement has been completely analyzed with the backend. That's what the response time is. And as well as the monitoring tools, we have Flash for backend processing and Prometheus for real-time metric visualization and analysis. So far, the key findings that I've come across with that, after this slide, I'll be showing you the live demo. But before that, let me just show you what I've come across, like the metrics. So for the metrics that I've come across in the local setup, like the frame rate is around 141 FPS. It is 141 because like I have a good hardware in my system, which is actually like optimized hardware, which it actually supports it. And input latency is 0 because like there is no certain input latency. Even if I move my keyboard, there are no certain delays like 0.1 second or 0.2 seconds delay. It's optimized according to it. And the response time is 96 ms. So it basically it ensures the minimal delays, and it is actually scalable for large scale applications. For example, basically I can also try a AAA game, but it actually relies on the hardware, and only with the hardware, not with the network. But the EC2 instance with the Flash server, the frame rate is about 164 frames per second only because I have a very good network speed right at the moment. There is no input latency, but the response time is 90 ms. But there are some high possibilities that it might not stand with the same frame rate and same input latency in the response time, because if there is high workloads has been implemented with the EC2 instance with the help of the cloud, if high workloads has been implemented in the Flash server, then there are high possibilities for the frame rate and response time to go down. But with the help of G-Unicorn server is actually a production grade server which has effectively reduced the latency and increased the frame rate, even though the hardware is less, even though the network is like a normal level. Because G-Unicorn server is actually it actually scales up to like high user loads, which is a very effective server at the moment. So right now, let's go to the demo. So first, I have this is actually the local, which is completely in the local server. So suppose if I'm moving the game with the arrow keys, this is just a block. I'm moving the block over the left. I'm moving the block over the right. I'm moving the block over the up and down direction. Then after that, here in the jQuery, the backend, it fetches the frame rate as 119, input latency is 0, and response time is 16. It has a very good response time. Here in Prometheus, I can actually come across with metrics. If I execute it, if I go to the graph, now we can see the graph. So at the moment is the frame rate was 119. As far as we have come across from 116 approximately to 119. This is with the local, and now this is actually the cloud, which I've implemented with EC2 instance in the Flash server. So if I'm moving the block left, right, up and down, here the same we have the metrics. So 118, and the response time is actually response time should be very less, but the response time is more. So there are certain delays, like if I'm using my arrow keys, there are some certain delays to move, even though if the input and the frame rate is optimal, but due to the response time, there is some certain delay on backend processing because there are huge amount of load over here. So this is currently 99. And then if I go to the Prometheus, if I check with the frame rate, and if I execute it, and if I just go to the graph, and you could see here the frame rate has been in 116, but in the local it was 119. So the frame rate has been reduced. And if we go to the response time, and if I execute it, and if you could see the response time has been increased. The response time is supposed to be less, but the response time has been more, which is actually, there might be a huge amount of issues might cause in the backend when the huge amount of workload has been presented. But so far, the input latency is actually less when compared to everything, because it's just a simple game. If it were a very highly graphic demanding game, then there will be an input issue, but input latency still stays in 0. Now let's go to the EC2 instance with the help of G-Unicorn server. If I'm just moving left, right, up and down, and if you see the metrics, if you see the frame rate, the response time is very less, which is 23.0, where it is processing the backend in a very good amount and there is no input latency and the frame rate still remains the same. But here we can just check again. I'm just moving the block up, down, left, and I'm just giving a little bit of stress into that. And right now, if I just check the frame rate, I'm executing it, you could see the frame rate is actually like more. Again, let's check it. It's just because like all of the three games, all of the three servers has been executed. And if I'm just moving the game right, down, up, and in the middle, if I'm just checking the frame rate, it's 122, which has been increased, and then there are some certain delays in the server, but it's all right. Meanwhile, the frame rate is 122 and the response time is 69. According to the stress, which is actually a very good improvement in the frame rate when compared to 116 and 119 with the help of G-Unicorn server. And if you go to the presentation and here, the backend optimization, we have used G-Unicorn for the production environment, which is very effective fix for the cloud gaming if it's completely used with the help of G-Unicorn server. And also it also integrates a virtual GPU capabilities for enhanced rendering and testing the real world. The main recommendations that I've come across is like to adopt a high architecture combining edge server and centralized vGPU cloud server. But right now we didn't have that much of resources. We have just used all the best resources that we could have right now, and also implementing advanced routing protocols and compression techniques. And the key takeaways the local edge server, which actually provide the lowest latency but lack of scalability for global platforms because it relies on hardware. And EC2 with the flash server, it is actually very slight improvements, but it's unsuitable for large scale deployment. If you give more stress into it and if you give more workloads into it, there might be an issues with the frame rate and the response time. But AWS EC2 with the G-Unicorn server, it significantly enhances the frame rate and response time. For example, if you come up over here, if I execute it, can you see the frame rate has been increased? It's just because the frame rate, let me just again go to the frame rate and then let me do some enhancement. Let me just move the blocks, and right now if I just execute it in the frame rate, it's still under 122, which is actually a very good improvement. And if I just go to the normal metrics of the cloud, it's 118, and in local it's 119. So G-Unicorn server has a very good boost in the frame rate. But recent times in the key findings, I've actually come up with a frame rate which went up to 300, 342, 348 frame rate, which is actually drastically the most highest frame rate, where this G-Unicorn server is currently a fix for this latency issue. According to my research, basically G-Unicorn server is actually a current fix for the entire latency issue. And in my future directions, I would explore hybrid architecture, integrating the edge and vGPU cloud servers, using the proper. But due to the availability of vGPU servers at the moment, I was not able to completely implement with the vGPU server in the EC2 instance. But in the future, I would be completely doing that, and I will also be testing the setup with the help of a real-time and a high complexity games like a AAA games with the help of the same metrics and everything in my future directions. And also I will investigate emerging technologies like 5G and AI based predictive algorithms for the future further latency reductions, because basically the edge does have a 5G network as its own ecosystem, which will be a very effective level of direction to test the games and testing the metrics, and also implementing the G-Unicorn server into that, which will be an effective fix as a future directive. So hope you would have enjoyed my presentation and hope you'd have had a great time coming across with the slides and the demo. So thank you so much for your time and have a great day. Bye bye.